Hey students, welcome back to another lecture or lesson in physics. We're going to do something that might feel a little new to you. It might feel a little bit overwhelming at first, but this is just a little bit of an introduction to things we'll do later in the class to kind of get you used to dealing with things what are called vectors. Now, vectors are quantities that have direction and magnitude. Now, we've dealt with numbers that are called scalar all of our life. We have a 3,000 pound car, okay, or we are traveling 60 miles an hour, or we've jumped 6 meters in the air, or we're hanging 6 meters in the air, okay, or we threw a ball 20 meters. Okay, so those are called scalar. They just have a number with a unit, 20 meters, 200 miles per hour. Okay, what a vector does, it adds a direction to it. And we deal with a lot with vectors in physics because direction matters, or the direction that a rocket is heading matters. The direction you're heading when you go home from school or you drive to your work or wherever you might be going matters. Not just your speed, not just your velocity, but that matters. So we'll say we'll be traveling. We threw a ball 200, we threw a ball 20 meters north, well, at a direction. We were traveling 600 meters per second due east, okay, or 45 degrees east. So that's all a vector is. A vector is a quantity of magnitude, a number with a unit with attached to it, but then it also has with it, it has the concept of direction. Okay, so what we're going to use in our vectors today, we're going to use an XY chart. We're going to use them, so you're similar to x direction going horizontally and the y direction going vertically. All right, so those two are going to be important for our concept today. And we're also going to introduce some review for those of you that have taken some geometries. And those of you or have not, this is going to be new to you. It's the idea of trigonometry. It's the idea of trigonometry and using right triangles. Okay, so if you remember a little bit of, so here's a picture of a vector. So a vector is that you have a vector that is 65 units in magnitude. So let's call it 65 meters. Okay, this is 65 meters in length, and it's going 30 degrees to the northeast. So here's north, or our y-axis is due north, and east is our x-axis. So it is going 30 degrees in this direction. So imagine that you've gone a distance. This would be 0. You've gone 65 meters and do 30 degrees northeast. Okay, likewise, you have another vector over here where you've gone. So here this time we have the y-axis still as the north arrow, and going to the left here on the x-axis is going to be west. So we have gone 60 degrees west. We've gone 35 meters 60 degrees west, 35 meters, 60 degrees west. So think of this as a compass, as you're moving a compass. So this has gone 60 degrees to the west, okay? So what we often have to do, if we think of these things as forces, oftentimes in physics, we have to think about not these as distances, but as a force. So what is the force moving in this direction, the east direction, and the north direction? What that's called is called resolving the vector. Now, you don't need to understand every little bit of this, but what we're going to do essentially is we're going to break the vector into two components, a horizontal component and a vertical component. And you can see by making it into a horizontal component and a vertical component, we will make a triangle. We'll make a right triangle. So let's just look at that right there. So that's what that looks like right there. We've made a triangle, all right? Then we've made a right triangle. So we have an X direction in both of these, and then we have a Y direction in both of these. And using trigonometry, we can find the magnitude. Now, in this case, since we said these are number, the unit attached to this number is going to be meters. So this is going to be 65 meters. We can find out how many meters this is, the distance, this distance, and we also can find how many is this distance. So if I was going to walk this distance and go up this distance to meet that vector, that's how far I would have to walk. All right. Same thing with here. What is the distance here? and here. Now for full, you'll kind of get this a little bit later when we actually study vectors. But for right now, we're just going to talk about how do we resolve them? How can we find the magnitude of the north vector and the east vector on this problem? And then on this one, how can we find the magnitude of the west vector and the north vector? Okay, so that's what we're going to do now using a little trigonometry. So here's a right triangle. Now you saw that these triangles here were right triangles. You see that there's a right angle. So there are some rules in relationships called trigonomic ratios. If you just think of them as ratios, that there is a ratio between the length of this side to all three sides work in fixed ratios based on the angle right here. So this angle, the magnitude of this angle will determine the length of this side, and with this side, which is called the hypotenuse. I'm going to describe what those sides are. So here's the angle we're always dealing with. And if we kind of we imagine shooting an arrow out of here, the side opposite of that angle is called the opposite side. The side next to it is called the adjacent side. And then the side that is the longest side is called a hypotenuse. So that may be something you might have learned in geometry before, maybe even some of your middle school geometry classes where you have an angle, the opposite, the adjacent, which is next to the angle you're dealing with, and then the longest side is called the hypotenuse. Now those ratios are broken up into three different, what are called sine, cosine, and tangent. We're not going to deal with these other three here, but they're just inverses or flipping those sine, cosine, tangent upside down. For our class right now, we're just going to deal with sine and cosine and tangent. And that's symbolized by so, koa, toa. Soa, koa, toa. All right. So to get the sine, if I want to get the opposite side, the length of the opposite side, that's called the sine. I take the sine of the angle, that little symbol is a sine of the angle, and the sine of the length of this side, the rate is going to be the ratio between the opposite side and the hypotenuse. So that's called opposite over hypotenuse. So you see SOH, sine is opposite over hypotenuse, SOH. So that's how we remember that, okay? Now the cosine is going to be the cosine of that angle is going to be the adjacent side, the length of the adjacent side down here at the bottom, over the hypotenuse. So this is cosine is adjacent over hypotenuse, adjacent divided by hypotenuse. So you see that these are just ratios. And then lastly, the tangent here, I'm trying to move a little piece out of my way here. I just can't get it to move. So the tangent is going to be the opposite over the adjacent down here. The opposite over the adjacent. So the tangent of the angle. Okay, so depending on what you have, what they gave you and what you're trying to find is whether you use sine, cosine, or tangent. Let me explain that to you right here. Okay, so for instance, we want to find the length of the opposite side, or what we would call the north vector. We want to find the length of this vector. Well, the one thing we're given this one right here. We're given that this is 65. So since we know the hypotenuse, we're going to pick one where we know the hypotenuse and we're looking for the opposite side. So which one of these has the hypotenuse in it with the opposite side? So, and that would be this one here. So we have the opposite side and the hypotenuse. So we're going to pick the sine. So we wouldn't pick the adjacent because we're not looking for the adjacent side. We're looking for the opposite side. So we wouldn't use that even though it has a hypotenuse in it. And we wouldn't use the tangent because we don't know either one of the adjacent side or the opposite side. So we always start with what we know. We know the length of the hypotenuse. So to solve for one of these other sides, we're going to have to include the hypotenuse. Okay, so we're going to use this one right here because we're looking for the opposite side, and there is the hypotenuse. So let me get out my pen here, and we'll do a little bit of our math together. Let me clear from last time. All right, so what we'll do here, and this is how we'll do that. So how we do that is we take the length of that side. So we're going to take the length of that side grab that right there. There we go. So we'll take the length of that side. And I need to, there we go, clear my work there. So what we're going to do is we're going to take the length of our side, which is 65, right? And we're going to multiply that times the sine of the angle we're dealing with, because the sine is the angle that we're dealing with. And the angle we're dealing with, remember this right here, theta. That theta right here is our angle. So our angle here is 30. So we'll do 30. Okay, so the length of this side is going to be 65 times sine 30. Okay, so hopefully I can bring up if you bring up a calculator, in your calculator, you would hit sine 30, and I just happen to know the sine of 30 is 0.5. So 65 in our calculator, and I'll show you this when we meet together in class. So we would do sine 30. So 30 sine, and we multiply that times 65. The length of this side right here is going to be 32.5. So this side right here is 32.5 using our ratios, okay? Now, the next one we're going to do is I'll get a different color for this one. I'll get a green color for that one. There we go. We need to find the adjacent side. So let's find something that has the adjacent side and the hypotenuse, because we already know that. So which one has the adjacent side and the hypotenuse? So we see the sine has the opposite side and hypotenuse, and this has the adjacent side and hypotenuse. That's what we're looking for. So we're going to use this right here. So this one, the cosine, is going to be, again, we're going to use what we have, 65. We're going to multiply times, this time it's the cosine of 30. So in our calculator, we'll hit 30, hit the cosine button, the COS button. That's 0.866. And then we're going to multiply that times 65. And that's going to be 56.3. So this side is 56.3. I told you those are meters, so we'll put little units on there. And so that is how we would determine. So if this was a length, or sometimes this might be a force. Let's say we've hit a ball and it's traveling at this speed in this direction with a force. What is the force in the x direction and what is the force in the y direction? So that's how we resolve the forces that are acting upon the ball moving in this direction, but also the ball's going up at some point. You see that? So this is how we break a vector into two pieces so we can better understand it. So that's what we'll be doing throughout this class, is doing problems with vectors like that. So what I want to do is I want to go ahead and try another one with you, and we'll resolve the other one, and then I'll leave you guys to practice some, and we'll do some in class together as well. So then again, we have let's get our pen back. There we go. So here we have this time our angle is 60 degrees. Our hypotenuse measurement is 35. So we know that. So we're going to be working with the hypotenuse. Okay. And so we're going to try to find the opposite side and the adjacent side, the x vector and the y vector. Okay. So here let's try the opposite side this time. Okay. So anything that deals with the opposite side and the hypotenuse is what we have. We're going to deal with the sine. So here we have 35, because that is our measurement over here. And then we're going to do sine of 60. Okay, the sine of 60. So in our calculator, we get sine 60 sine times 35, and that's going to give us 30. We'll round to the nearest 10 to 30.3. So this is 30.3 meters. Okay. And then for our adjacent, we'll find the adjacent side. We'll pick a different color for that. We're going to do, since we're dealing with the adjacent, we're going to deal with the hypotenuse. Adjacent and the hypotenuse. So here we'll go 35. And this one, instead of sine, is going to be cosine 60. And that's going to be, so we'll hit 60 in our calculator, hit sine times 35, and that's going to be 17.5. Okay, so this is 17.5 meters, okay? Oops, let me get that color out of the way. There we go. Okay. Now you might think now that we have these two sides, so let's just say we are given these two sides. We were given the y and the x. Could we find the resulting? Could we get to 35 if now that we have these two? And we could because the tangent is the opposite over the adjacent. So what we could do here is we could take our 17, I'm sorry, our 30 right here. That's our opposite side. Remember, the opposite side is the one that is if you shot an arrow out of the angle, that's that side right there. The adjacent side is one that's right next to it. So if we did the opposite over the adjacent, so the tangent of 60 is going to be the opposite over the adjacent, okay? And we could find that ratio. So if we take 30.3 divided by 17.5, 30.3 divided by 17.5, that equals 1.73, okay? So that should mean that if our ratio is right, the tangent of 60 degrees should be 1.7 since I set them equal to one another. So let's go ahead and put 60 into our calculator, hit the tangent button, and I get the tangent of 60 is 1.73. So they do equal each other. So this is a way to check yourself. But for now, what I want you to understand is just be able to recognize the x vector, the y vector, and what trigonomic function or which trigonomic ratio you're going to use. For now, I'm not going to make you memorize these, but it's healthy and helpful to have SOA, S-O-H, COA, C-A-H, TOA in your memory banks, okay? So we'll have this available to you to work out these problems. So that is our lecture and our lesson for today. We'll talk more in class, do some practice problems together, and also gave you some work to do for our next time too, so you can get some good work in. So I'll see you soon. Bye-bye now.